Um, so let me talk about what we're going to do today. And what's coming up. So the first thing is we're going to have our first quiz tomorrow. Um, so you had that's not how you spell tomorrow. Um, you had the videos on mechanical, electrical, and civil engineering, the three biggest branches of engineering. And you'll have some videos tonight on three other sort of relevant areas of engineering: biomedical, petroleum, and chemical. Um, and largely, I chose those three because they're relevant regionally. Um, there are a lot of other branches, but and so, with those six engineering disciplines, that's what the quiz is going to be on tomorrow. And it's just going to be a short quiz asking you like to remember kind of the key points of these things. Um, and it'll take 10 or 15 minutes. That's it, right at the start of class. Um, Anybody have any questions about the videos or the notes or anything from yesterday? Okay. Uh, One thing I said I was going to do and I forgot to do, so we'll start with this today. Is um, so first I want to show videos of previous design projects and robotics projects, so you can get a sense of like the scale of what these things are. Um, and then we're going to get back into just working through CAD, Fusion 360. And last time we did sketches and extrudes and dimensioning. We're going to do all that again. This time we're also going to talk about, so we'll talk about the features bar. Um, we'll talk about once you've made something, how you can measure dimensions or measure distances. Um, Remember that when we put dimensions in yesterday, we did it all in the sketcher. So all the dimensions that we put in yesterday were in 2 dimensions. So now we're going to talk about, you know, how to measure things in 3D. Um, and we'll talk about revolves. Actually, let's do this later. I'll put this a little lower down. Reference points and lines. Um, Points, lines, and planes. We'll talk about patterns, which are really useful if you have repeating things going on, especially if you have a ton of them. You might not want to go through the steps of making a feature over and over again. Like imagine spokes on a bicycle or something. They all look the same. They just follow a pattern as you go around the wheel. You probably wouldn't want to do, um, 36 separate drawings. You'd want to do one and give it a pattern approach. Um, and then I don't know how much we'll get to today of this, but we'll talk about revolves, which are going to be a really important thing for us. And then last, we'll talk about orthographic drawings. Um, the handouts that I gave you are examples of orthographic drawings. Anyone know what ortho means mathematically? Yeah, that's right. So an orthographic drawing is just an engineering drawing that shows three perpendicular views of a part and with the dimensions shown in, you know, useful places. So that's what I gave you an example of. This is the part that we're working on right now. And it shows the three perpendicular views. Um, and then in the kind of clearest places that I could think of, it shows the dimensions in those using those views. Uh, it looks actually like, as I look at this, um, I should have um, so in the view that looks like this, it doesn't look like there's anywhere where I gave a height of that shape. So there should have been a dimension here uh, showing that this height was 0.4. Like a good orthographic drawing should give you all the dimensions you need to create this shape. This is something that you would send to a machine shop or something if you wanted this part manufactured for you. Okay. All right, well, let's start with the videos. So this is kind of a glimpse at the kind of things that um, we're going to be doing in this class. So first, I think I have three examples of the design project. And these design projects are primarily using CAD and 3D printing, although I'll also bring you into the Fab Lab and you can see what other kind of things we have available if they're useful to you. But you're going to design parts, products using Fusion 360, and then we're going to 3D print them. And you're just trying to design products that have some kind of utility, something in your life that like, this stupid drawer won't stay closed, or, or I have a specific need for hooks near the door or something. If you have a need for it, presumably maybe other people have a need for it. And so let me just show some video of some things other people made in the past. Um, okay, so this is just a jewelry stand. Um, and as you do these things, a big part of this project is going to be detailing your thought process. Uh, so like, for example, uh, why did you choose to make the base this size? You know, um, why did you choose to make the trays this size? Why did you choose to make the edges here rounded off? Why is this hollow? Those are the kind of details that I want you to think about, and I'm going to want you to be able to make clear in your reports on this thing. And you'll do, little written reports at the end. Okay, there's not much to that one. That's what you see is about what it is. this student does a lot of crocheting and wanted a way to store crochet hooks. So, you can see there's places for they just stand up nice and straight, don't take up a lot of space on the desk. There's a thing in the middle for unpredictable things, like, for example, this one had a funny end, so there's a sort of a miscellaneous storage thing in the middle. And we're just gonna, when we start doing this project, we're gonna spend some time thinking about what are your needs, what do you want this thing to do, looking online for similar things, how can you come up with something that meets your needs better than what's available. And then the last one is a multi-piece thing. This is like a wire organizer. So you can see each one of those little segments is a separate part. These were connected using pieces of paper clips. And so the idea is that when you're not using it, it can, fold up and store nice and small. And then when you want to use it, you form it back into that octagonal shape or whatever, however many segments there are. And then you just wrap the wire around. And sort of, whether it's the best working wire wrap in the world, I'm not sure, but it is kind of a cool, unique take on it, And so we'll get to that in not too long. I guess with this class being accelerated, maybe even we'll start talking about it tomorrow, I suppose. And you'll have quite a bit of time to work on it. Anybody have any questions about that? So we also have laser cutters. We have, saws and drills, and we have a CNC mill also, so that can do aluminum really easily. It can do steel, but it's a little more finicky. But so we'll go into the Fab Lab and talk about all that stuff. But so that's what's coming for the first project. That's the design project. And that's going to be an individual one. Everyone's going to do their own thing. And when we're done with this, anybody who is willing to have their things shown, we'll spend a little time in class after everybody has these back, showing videos like this. And if people have questions, they can ask, just to sort of see what other people have worked on. And then next is the robot project. This will be the second big project. I said I taught this class in 2008 and 2009. So this was a set of the robots that were made back then. So this is a really old video. Spring 2008. So this first one is a card shuffler. So it's all made out of these, whatever kind of set this is. And these wheels spin as long as, so there's an optical sensor here that's looking for light, and the cards are all in here. And so when there are any cards in here, this optical sensor can't see any light. So it knows that it's not done yet. And as long as it's not done, these wheels are spinning. and the spinning wheels shoot the cards in here, ideally sort of randomly. And then once all the cards are out of here, um, the optical sensor sees light, that turns off, and this tips up to drop them back in there, and it goes through as many times as you want. So you can see, oh, I had it backwards actually. So it's shooting the cards, the optical sensor is on the left side, it's shooting the cards to the right, and when all the cards are gone, the wheel stops, it tips it back into the starting place, and then goes through it again until you turn it off. Let's see. This is just a sort of a automatic drawbridge. That bridge is down until sensors on the sides see something come up to the bridge, and then it tips up and allows the thing to go through. As you go through these projects, as you're working on them, I mean, the grades are going to be largely based for the design project and the robot project on how much thought you've put into. So this thing worked well. It looks nice. I think ideally, I would like to see more thought going into like the utility of this thing, you know, like what's the point of just having this bridge that opens when anything pulls up to it? So like that's the kind of place. I mean, they got a perfectly good fine grade on this, but that's the kind of thing to think about. Like, what can you do to make it more useful? What can you do to make it more reliable? That kind of thing. And all that is going to be detailed in your for this robot project is going to be a group project, and instead of writing a design report for the group project, you're going to do kind of make a video that's sort of like a manufactured presentation. So you'll talk about similar things that you found on the internet, what you want to do, why you want to do it, what changes you made, and we'll talk about the format of that as we get closer to it. But it works really nicely. It's really well made. Okay, this is a. We'll see in a second whether. So, I think this is going towards like a target object. So it's scanning the room for. I didn't give that one much video time, but it's scanning the room for some target object. When it sees it, it goes towards it. Keeps scanning. Little by little, it works its way over there. This was the most terrifying one. They found this old refrigerator at like a dumpster or something and cut a hole in it, and they have this motor-driven thing that when you press the button saying you want a Coke, it launches Cokes at you. Look at this kid; he's terrified. That was a pretty funny one. Everyone liked that one. Looking back at it, like what are the things that could be improved there? Well, just the idea was fun. It worked reliably. The execution could have been a little better. It could have looked more professional with the cutout. It could have been more sort of more planned out, the trajectory that it was going to send these things at, because it was pretty hard to be ready for this thing that came launching out. Obviously, you're under time constraints, and that's taken into account. But just as you think through this, that's the kind of thought that I want you to have. Here's one that's like a different group, but it's a companion to the card shuffler, automatic casino, full casino. This is a card dealer. And so it just rotates around and hands everybody there. I think it was a blackjack dealer only. Their original plan was to program a bunch of different card games, but they sort of didn't get around to it. I think this, oh, this is Legos. I think the other one was like an erector set. Um, this was before we had the Fab Lab. So now we have the ability to manufacture sort of more carefully some nice looking parts. And so you will you will be, you know, grade wise be rewarded for doing um, nicely made parts for your robot. Let me show some of the more recent robot examples that I liked. Um, okay, this is, so this one is a drink mixer. I think it was, they had lemonade, iced tea, or Arnie Palmer. Um, and so they had a sensor here so it wouldn't pour liquid into empty space to make sure that there's a cup in there. When you press a button, you can't see it here on the video very well. Oh, yeah, you can. So you can see what you ordered. You put your cup in there and it fills it up with whatever you want. This was great execution, great simple idea. Um, the the execution could have been much more professional. You know, the labels are ugly. The thing is just sawed out of wood. We have the ability to make much more careful looking things than that. So, I mean, they got an A on this project. But if you're thinking about how to improve this project, that would be my first thought. I love the readout screen. Um, then here's one that, for some reason, the video they sent me doesn't show the thing actually following the line, which is weird because I know it did. But they made a vehicle that if you have a dark line on the floor, it'll just follow it around. It's a simple idea that has been done a million times before, but I have it in here because their execution was really good. Um, So notice that the chassis is all 3D printed. They made that chassis very carefully with cutouts for what electronics they would need. And then once you can see over here on the right side, when the camera moves a little bit, you'll see that they actually have a printed circuit board for part of their electronics to make the electronics nice and clean. That's not something that I normally do as part of this class, but if you want to talk about it, we do have a circuit board printer. And so um, they put a lot of time into getting that working, and it came out really nice. There it is, the copper one. Let me pause it there. So you can kind of barely see it. This is a copper sandwich board that that mills away electronic paths, like basically mills wires into this sandwich board. And so you can make, so instead of having wires going everywhere like this allows you to have your wires uh, all printed out of the same thing, very close together, very reliable. It's not going to break. No wires are going to fall out of pins and stuff like that. They actually tried to do, they wanted to do more of their wiring with that, but I think only one of their boards worked. You know, it's a little finicky getting it to work, but um, this is the coolest project in the worst video. You can't even see what it looks like, but uh, so I think what they're doing right now is calibrating the light sensors to sort of what black is. And then once they do that, um, then they can put it on the path. and it'll follow that path around. This one is, there's kind of like, you can make ones that are sort of crowd pleasers because they're sort of whimsical or whatever, and you can also make ones that are just really useful. This is more just one that would be so useful to have in your house. This just detects leaks. So they have a liquid sensor that's just detecting when water is leaking out of the pump, out of the pipe, and when they detect it, that turns off the pump so you don't end up with water everywhere. They've they have this valve in there, so they kind of manufacture this leak, and I think the sound of the room isn't on right now. But when they pull that cap off and it starts to leak, you can hear that there's a pump going sort of all the time that's pumping water from here over to here. And when they pull that off, the pump stops. And then the last one I have on here is a coefficient of friction measurement. You could use this in like a physics lab or something. So they have, so if you've taken physics 1 in high school or here, you know that for dry friction that doesn't involve a viscous liquid, you basically have a linear relationship between how hard something is being pushed down on the surface and how much friction there is preventing it from moving. And that linear relationship is the constant proportionality in that linear relationship is called the coefficient of friction. And so they have this wheel that spins and this block that they put a known weight down. And then they have force measurement devices measuring the up and down force, and then also measuring the horizontal force. And they're using that to measure for their pair of materials what the coefficient of friction is. So right now they're measuring the coefficient of friction for wood on wood. This one, I mean, all of these projects were really good. Again, that one could have used the Fab Lab to manufacture it a little more, professionally looking. But the idea was great. The execution was great. It worked reliably. And I think it showed the screen briefly. So it on the computer screen, it gives you instructions, and then once it has enough data and the data is giving it a stable value, it tells you what that coefficient of friction is that it measured. Okay, so that's the idea. And it's going to be really fun. I think these projects sometimes seem a little intimidating at the start, but we'll go through all the stuff you need, and as your specific project starts to have specific needs, I can talk to you about those things one-on-one. Also, now in the age of AI, you can get so much help by just going to ChatGPT and asking, specific questions about programming specifically, but also about wiring. Anybody have any questions about any of the projects? Those two projects are basically what this class is about, and all the skills that we learn are kind of just put in as we build up to these two projects. And then all of the skills that we're learning in this class are things that'll come up again in later classes in sort of a more full format. Okay, well, let's get back to the CAD project. So we're working on this this block with the holes and the cutouts. Why doesn't everybody go to so you can go to your web browser and type in Fusion Online. And launch Fusion. Oh, yeah, sorry. Anybody else need a laptop? And I think let's just start over again as a review. Extrude is such a fundamental feature. Let's go back to our folder, and we're going to start a new part and do the steps over again that we did. It won't take very long. And I'll wait a second. Who's still working to get into Fusion? Okay. Yeah. Yeah. Is it still thinking? Okay. Let me know when it either crashes or opens.
Is it good with Mac? Or is
I don't think I've seen any problems with Macs specifically. I don't think so. For the people who are in, I guess, go open up. So there's this icon at the top that's says data panel. And if you click on that, it opens up your folder tree, and find that project rectangular box that we made and double click on that to get in. Is it in yet? No. But it doesn't have an error or anything yet?
No, not yet.
And yesterday it opened faster than this? Huh. Well, we'll see. We're going to do a new part. We're going to sort of start this over. I'm in the folder rectangular box. So I'm going to close that file tree. And so I'm just focusing on the part that I'm making. And so what's the first step that we're going to do to extrude this part? Anyone remember? Just trying to jog your memories. Yeah, so we want to do a sketch. So I'm going to go up here. This is the sketch thing. By the way, you can always, any of these things in the create section, you can always pull down the full drop down menu. And all of the things are there, but some of the more common ones to use, they're just big icons here. So we want to sketch. And it really doesn't matter what plane you put it in. I always go to the lower right quadrant so that it stays in the plane that we're looking at. And now in the sketch, I want to make a rectangle that has one dimension of 0.4 inches and one dimension of 0.5 inches. So I'll go one corner there, one corner there. Before I can go to the dimensioning tool, I need to cancel out of the rectangle tool. So I'll go right click, cancel, and now I'm ready for a new command. And I'll go into this create drop down menu and go to sketch dimension. And I want this height to be 0.4. I have 2 periods, I guess. And I want this one to be 0.5. And so now I can finish this sketch. And go back to my home view. So we can sort of see the more three-dimensional view of what we made. Okay, so now that we have this sketch, who remembers what we do to extrude this? Yep, this extrude. At some point, we need to choose what we want to extrude. Even though we only have one thing, it's going to ask you to select that. So I'm going to do that first, but you actually can do it after you hit extrude. So I'm going to highlight that. It all turns blue to show you very clearly what the profile is that you're going to extrude. And then hit extrude. And it shows you this arrow, which tells you what positive numbers are going to be. So if I type in, we want this to be 2 inches. And so if I type in a +2, it's going to extrude that way. If I typed in a -2, it would actually go, it would extrude down. Let me show you what that looks like. Okay. And that's going to be, that positive versus negative thing is actually going to be really useful when we start extruding cuts. Like just like you can extrude solid things, we'll see that if you do a sketch on material and then extrude into the material, what it does is cut that extrude out of the part that you already have. Okay, so now we have this. I'm going to use 2 fingers and drag down to get where I can see this whole thing. Just zooming out. You also can use the hand to drag it around. 2.0. Yeah. And you can see that on the, if you look at the handout I gave you, you can see that the length of that is on the bottom left shape. You can see that that length is 2. Yep.
How do you exit out of extreme? Like,
Yeah. There's one more dimension that we haven't done yet. We haven't told how big the circle is. So if you're still in dimension, if you haven't quit out of the dimension, you can just go to the circle until it turns blue. Hit the button to select it. And that's a diameter. Mine currently is 3.43. I would just want to make that 0.3. Any questions? Okay, so now we're done with this sketch. That hole is the size we want and it's where we want it. So I'm going to click Finish Sketch and it goes back to the home view. And just like before, now we're going to extrude it. So I'm going to go up to the circle and highlight the shape that we want to extrude. And I'm going to click the extrude button, and it, I think, always guesses that we're going to want to extrude material out from the material we already have. In this case, we don't want to do that. We want to go the other way. So I'll pull it that way. And there are two ways we could do this. We could, I mean, if I said I wanted to extrude this 1.7 in the negative direction, that would work perfectly fine. It would look like what we want. But there's a little bit of a better way to do it. And that is to go to the extent type and just tell it we want it to go through everything. Okay, that way, if we decide later that we want these dimensions to be different, we would never get to a point where that doesn't go all the way through it. So I'll go to extent type, go to the bottom, all. And now whatever size this was, it would go all the way through. And if I click OK, now you can see that that's a hole. So I just use the rotation tool to move it around a little bit so you can see that it goes all the way through. Yeah. So this is the extrude, and you have a direction that says from where you are, you can move in both directions, or you can just move in one or the other direction. We have it just going in one direction. And then the extent type, what we did before was we extruded a distance that we chose. This time we're going to choose the all. Well, you don't need to enter a distance if you click all. I think that option goes away because all it says is it's going to make this hole go through everything. All right. Any questions on that? Well, there are two ways we could have done all these holes. We have 4 of these holes. And we could have made, in the sketch, we could have drawn these 4 circles and spaced them out the way we want them. And then we could have done the extrude and extruded everything out. But what we're going to do instead is we just placed this 1, we extruded it, and now we're going to say with this extrude, we're going to follow a pattern to extend 3 more this way, a total of 4 this way. And so to do that, we're going to, so this is the first time I've mentioned the feature bar. And this is a really useful thing as you go. Notice that down here, each one of the steps we've taken appears. So this first one on the left is our first sketch of the rectangle. This one is our extrude of the rectangular solid. This one is the sketch of our circle. And this one is the extrude of our circular hole. And you can right click on any of those and go to edit, and it'll get you back into that thing so you can make changes. So like if I right click on the original sketch we did and go to edit, it brings me back into that sketch, and I could change those dimensions or anything I want to do. And the same thing with the extrudes. If I click on edit feature, it'll open up the extrude and I can change the properties of that extrusion that I did. What we want to do now is, instead of editing something, we want to make a pattern out of one of these things. And what we want to make a pattern out of is the extrusion of that hole. And so just left click, regular click on that extrusion to highlight the hole. And then go up here to create, and down about 2/3 of the way is the pattern. And there's a few ways that you can do patterns. We're doing the simplest one. We're doing a rectangular pattern, and it's called rectangular because you could have it go, you could have it patterned this way and then this way, like an array. We're basically just doing a one-dimensional version of this rectangular, so we're just going to have the pattern extend in this direction. So I'll go to rectangular pattern. You can see that the object I want to pattern is already selected. It says one selected. That's what we did before we got into this. And so all I need to do, well, not all I need to do, but the next thing I need to do is choose what direction I want this to extend. And so all you have to do is choose some line that's parallel to the direction you want this to extend. So I could highlight this line or this one. If I highlighted this line, it would make the holes go out this way into space. Okay, but so either of these two will make it go that way. So I'll highlight this. And when I do that, you can see that the arrow is guessing the correct direction. It could be, that arrow could have guessed the other way, and then I just have to use negative numbers to tell it this way. And also notice that when I highlight this axis, a second arrow appears here, guessing that for your second direction of your rectangular pattern, you want it to go this way. We don't care about that, so we're not going to select any more axes. And now we want to, so there are two ways you can do this. You can say, well, let's first do the quantity of that we want for the pattern. We want 4 total, so I'm going to put 4 in. And then I'm going to go to how I want these measured. And there's 2 ways we can do it. We can tell it the extent from the beginning to the end of our pattern, or we can do the spacing between each pair of ones. Based on the way our instructions are given on the orthographic drawing, we probably just want to use the spacing. So I'm going to go down here, choose spacing. And now I need to give it a distance for a spacing between these objects. And we want to give it the spacing from the center of one feature to the center of the next feature. And so this is going to be 0.46. And you can see as you enter stuff in, it's showing you what would happen if you clicked OK on this. Yep.
Mine is going to the left.
Oh, okay. So it's the way we want it to be. So I'm going to click OK. And now it makes holes out of all of those. And that's the thing again, like if you're doing a part that has 150 spokes on it, the last thing you want to do is spend a whole afternoon making 150 separate things that are identical. So this pattern, and if you are making spokes, by the way, you wouldn't do it in a rectangular pattern because they need to follow a circular path, and so you would go to their, I think it's called radial option, circular pattern. Okay, so yes.
When I click it okay, it's just weird.
Okay. Yeah, this kind of stuff happens all the time.
How do I go back?
So this is this screen. Oh, so they are.
But it was actually great. You click on the you get to it.
Let me go back to this. It's a little loud. These 0.46. 12.3. I don't know. Yes, no problem. I think maybe if you notice down here on the features, there were two extrudes there that seemed related in some way. And so maybe it was something with that. All right. So now we have this. And I guess now would be as good a time as any to talk about. So say you have a shape like this and you want to know like the distance between 2 points or something. How would you take measurements of your three-dimensional shape? If you go up to this, when you're looking at it in 3 dimensions, if you go to this inspect thing, you have a bunch of options, and one of them is a measurement. And so that's not the one I want. Inspect measure. And you can highlight one thing and it'll tell you the length of it. You could highlight a circle and it'll tell you a bunch of information about that. If you highlight 2 things, it'll tell you the distance between them. So say I wanted to measure the distance between the center of this circle and this face. Now, both of those 2 things are highlighted. So, well, I guess it didn't go from the center to here. Instead, what it told me was since they're different distances from different parts on the circle to this face, it told me the minimum distance is 0.1 inches from this point on the circle to the face. The maximum is this 1.4 from here to that face. If you highlight a line, it'll just tell you the length of that line. You can see that length is 2. If you highlight a circle, it'll tell you the diameter and the radius. So that's a really useful thing as you're trying to get your shapes. I think if you highlight 2 points, it'll tell you the distance between them. So I just highlighted that corner and then this corner, and the distance between those is 2.1.
So find the distance to the center of the circle. The way it shows that. I guess how you have that.
Yeah, probably. But it's possible that in order to do that, what we have to do is construct a point. So I was kind of expecting there to be a point as an option to choose here, but it's not there. And so that's something that we're going to talk about for the next thing is sometimes you want to put things on your part that are not actual physical things. They're just for reference for you to make other parts off of or something. And so what we're going to do in order to make these cutouts, we're going to make a plane that cuts down the center of this, and then we're going to refer to that plane as we make our parts. And so you can do the same thing with lines and points. If we wanted to measure from the center of this circle to this side, we could make a reference point here. And let's see, I'm sure that's easy to do inside a circular shape. So let's say we'll go to construct, and we want to make a point at the center of a circle. Okay, so I'm gonna just highlight this circle to start with. And then I'm going to go to construct, and I'm going to go to point at center of circle. And then it makes the circle that you want. Now that we have that reference point there, now we can highlight that point and highlight the side and go to measure. And are they both highlighted? And now the distance between them is 0.25. So that's the idea of these reference things, although this isn't the one that we're going to use for the cutout. Instead, we're going to make a sort of center plane. All right, so now to make these cutouts, um, we want to cut a little, kind of like chisel out a little inscribed rectangle on this side. And then we're going to want it on the other side too. And we prefer um, not to have to do it separately 2 times. But it's not a pattern that we can use here. You could think like, oh, well, it's a pattern. We want to flip it over here. But none of the pattern tools that are given are going to let us do that. What we're going to do instead is we're going to make the cutout on one side. Then we're going to make a plane down the middle. And then we're going to use the mirror command to make something that's symmetric about that plane we just made. And that'll cut it out at the other side. Can you sort of physically visualize the way that works? And so we're going to start by cutting a rectangle out of this. Well, we're going to do it again with an extrude. And so in order to do an extrude, we first have to choose where we want to sketch our shape. And so I'm going to do that on this side. And go to sketch. And then I'll use the rectangle tool. And this is a place where I'm going to make this rectangle really like crazy shape to keep it from guessing at how big I want everything to be so that I can specify it myself. The way that it guesses at sizes you want causes often like more problems than it's worth. So now that I have this rectangle here, now I'm going to go to the dimension, the sketch dimension, and I'm going to highlight these two, and I'm going to say I want those to be a distance of 0.05 apart. And I'm going to do the same thing a total of 4 times, 0.05. Well, actually, I shouldn't have put this outside the body, because I think now if I make this 0.05, it's going to keep it outside the body. So instead, I'm just going to specify the length of this, which is going to be, so we know that the whole width is 0.5, and we want to subtract 0.05 from one side and 0.05 from the other side. So I'm going to make this 0.4. Oh, no, it's not 0.5, it's 0.4. So I'm going to make this 0.3. There we go. So now everything, all those distances from the edge to the rectangle we're making is 0.05. Yep.
It's giving me.
Okay, yeah. And go to extrude. And like I think it always does, bless you, it assumes that you want to create more material. So I'm going to drag this the other way and say, no, I want to remove material. And I want it only to remove material to a distance of 0.05. And then when you hit OK, you get that little cutout. All right. So now we get to we want to mirror this across the center across a center plane, but we don't have any way to select a center plane. There's nothing there. And so we're going to use that construct idea to construct, and we're going to do an offset plane. Okay. And so if you want to create an offset plane, it's going to ask you what plane you want to offset from. And you can basically select any flat face as your offset thing. One thing you can do is, if you can get enough detail for it to select this, you can zoom in to do it, for example. You could select this rim here around the outside. We also could select this face of where we've cut, but then we have to do a little bit of math to figure out how far we want to offset this center plane, because this is not all the way at the edge. So if we do it from this outer one, we want to offset it in this direction, 0.25 inches. If we do it from this one, we'd want to offset 0.2 inches. Or we could rotate it around and offset from this other one. That's easier to select, and it would be 0.25 inches that way. So those are three good options. We don't want to select this one or this one, because this plane is always going to be parallel to whatever you select. So I guess I'm going to highlight this. And it asks what distance we want to offset this plane. We want to go this direction. And we want to go a distance of 0.2 from the one I selected. And now you can see if I rotate this around, this plane goes right down the middle of those circles. So it's right down the middle of that. Yeah. Oh my God. Okay. Well, it goes right down the middle of the shape. And now what we're going to do is we are going to highlight this cutout that we just made, and we're going to tell it to mirror it across this plane that we just made. So this down here on the feature bar is the extrude that created that cutout. And now I'm going to go to the Create drop-down menu and select Mirror. And you can see that it's all, since we already selected that extrude, the object is already chosen. Now we have to choose the mirror plane, and we're going to select this plane that we just made. And once I did that, you can see that it's suggesting where that cutout is going to be, and it looks right. And so I'll hit OK. And now if you rotate this around, you have those cutouts on both sides. Okay. So there's that super useful thing that we've made now. I think it's pretty obvious what this would be used for. Just kidding. Yep. Oh, okay, yeah. Well, I don't know. It's something. It's not working great today. Normally it works better than this, but that is probably a reason, a reminder that it's a good idea to go up here and save every once in a while. Um, this part, I mean, I'd be happy um, to email you this part so that you have it. Yeah, sure. Um, it's not something we're going to use again. It's really just to get used to doing these commands. Um, I want to show you a couple of things that you can do that they're largely cosmetic in high force engineering applications. Sometimes they can be useful for reducing stresses in objects, but that is chamfers and fillets. And so fillets are, if you take a sharp edge like this, you can round it up. Excuse me, round it off, and you can do it on internal edges like this or external edges like this one. Um, and all you have to do is select the edge you want and then go up to construct, I think. No, modify probably. Yeah. And there's the fillet and chamfer. Um, and if you use the control button to select a chain of edges, you can do them all at once so they all have the same fillet radius. So like, let's say that I want to go, for some reason, I want to round off all 4 of these edges. I'm holding down the, oh, oh, there we go. I'm holding down the control button and selecting those. So now I've selected all 4 of those. And now I can go up to modify and fillet. And it asks me what radius I want for my fillets. If you pick a small radius, it's going to be closer to a sharp edge. If you pick a big radius, it's going to be more rounded. So let's see what happens if I 0.1 is maybe a little big. Let me go 0.04. And you can see that all of those edges that I selected are now rounded off. In this class, the main benefit of using fillets or chamfers is just going to be cosmetic when you're making things that you think look nicer with rounded edges. Or a chamfer is similar. I'm going to cancel this thing. So I'm going to highlight these fillets that I just did on the feature bar, and I'm going to delete them, and it'll go back to the way it was before. A chamfer is the same idea, but it instead of rounding the edge, it just basically flattens the edge, makes a diagonal flatten. So if I do the same thing with a chamfer, go to modify, and it asks a distance. I think that's a length of the flattened piece. So let me make that 0.04 again. And you can see you'd use it for a similar purpose. It's just flattened instead of rounded. And if this is being manufactured in like a shop, depending on what techniques they're using, this could be easier to manufacture than a rounded thing. For 3D printing, there's no difference. A 3D printer will do a filleted edge as easily as it does a chamfered one. I'm going to delete that again. Cancel. Okay, so that's back to the original. I want to show you too, actually, I guess I'll get to the revolve and the orthographic drawings tomorrow. I want to show you before class ends how we can share files. So if you wanted to now share this part, like you're going to need to do sometimes to turn things in, there are two steps to doing this. So first, we're going to make an F3D file. That's just the format file that allows us to share this. So we'll go to export. So go up to the file icon at the top and go to export. And we can name it whatever we want. So rectangular box. And you can see that it gives you a few options for how to share it. We want this F3D file format. And when you hit OK, it's going to put an F3D file of this part into your folder. Well, I'm going to reopen the project folder. And it says something in this folder has changed, refresh. And now you can see that there's this F3D file in your folder. Okay. And so now, let's see, I'm going to save this part. I haven't even named it yet. I'll call this box day 2. And I'm going to close it. And I think maybe I'll open the F3D file first before I close it. Oh, this works even better. Shoot. I think maybe we're all about to get timed out of this and it's going to have to reopen again. You don't have to open these again right now, actually, if you don't want. You can just like look at this later and see how to do this. But now that I've opened this F3D file, I can just go over here to the download icon. And if you download that, this is like sort of a long process of little steps. But now if you go to your download folder on your computer, that F3D file is in there. And then you can submit that to D2L or whatever to turn in assignments. Okay, so what if you're trying to share files with each other? So say that somebody sends you an F3D file, how do you open that? So that's what I want to do next. Okay, so I'll open up the folder tree. Let's say I want to go into rectangular box. And now what I want to do, if somebody has emailed me this file, is I want to upload this file. So I'm going to, when you're in the folder that, or the project that you want to be in, click on upload. And it opens up this new thing and say you want to upload something, a file. And we want to get it from the downloads. I'm going to just get that file that I just put in downloads. So now I'm just browsing through my computer for the file I want. Rectangular box F3D. And now if I go back into rectangular box, into this project, it should be in here. Let me try first deleting it because I'm trying to put in something that it already has. So let's say that F3D file was never in this folder. Oh, all right. So I'm gonna go through those steps again. So I'm in the project that I want, rectangular box, and I want to upload something. So I'll click upload. I want to get a file. I want to get it from downloads. And so there it is. And if I go to this folder, maybe I just have to be a little more patient, but eventually, so now it says there's new, something in this folder has changed. Click refresh. And now it's put that file into my folder where I can now work on it. Okay. And now I can go here, click on open, rectangular box, and there's the part. And now I can mess with it or whatever. Okay. So like in the case that your program crashed and you didn't get the part and I have to email you a part, that's how you would get the part that I would send you. Anybody have any questions about that? Okay, man, that was a full day of this stuff. There's not going to be too many more days. I don't think we're not going to tomorrow take even a full day of this stuff, but tomorrow is going to be, I think, the last day of tutorials like this with Fusion, and then you'll have some time to work on design projects and things. Okay, well, in the next hour or so, I'll get the assignment up for tomorrow, and I'll be here from 1 to 3 if you have any questions, and see you tomorrow.